Welcome to today's video. We'll pick up where the first video left off with number 7 here. And remember, this is not a rational function, so we can't observe highest powers. But what we can do is use the limit rules. And the limit rules say that you can multiply by the highest power of x. Because this isn't a radical, we'll multiply by 1 over the square root of x squared on the numerator and the denominator. That way we can simplify the radical. So here, when we simplify that, we get x plus 1 in the numerator over the absolute value of x, because that's what the square root of x is. And in the denominator, when we multiply here, x squared over x squared is just 1. And then x over x squared is 1 over x. I'm going to go sideways here because I'm going to run out of room. So then we have the limit as x approaches negative infinity of, if you split up the numerator, you have x over the absolute value of x plus 1 over the absolute value of x over the square root of 1 minus x. So from here, the limit of x approaches negative infinity, x over the square root of x over absolute value of x, when you put into negative infinity, that means this is going to be a negative number, and that's going to be a positive, so it's going to be negative 1, plus 1 over x squared, 1 over the absolute value of x, when you go to, and we'll talk about that in a second when we take the limit, over the square root of 1 minus 1 over x. Sorry, I initially had put x here. It should be 1 over x. So now we can take the limit as x approaches negative infinity. So this is negative 1 plus 1 over infinity over the square root of 1 minus 1 over infinity. Well, 1 over infinity, remember, is 0, so this is negative 1 plus 0, over, this would be the square root of 1 minus 0, so the square root of 1, which is 1. So it's negative 1 over 1, which is negative 1. So that is our answer for that one. Now moving to the next ones, 8 and 9. So why don't you, because 8 and 9 are similar to what we've done before, why don't you give it a try and then pause the video and then come back and see how you did. All right, so welcome back. So now if you look at the first one, number 8, when you put in 0, it becomes indeterminate. So therefore, you have to do some algebra, multiply by the conjugate, and you should get that the answer is 1/2. For number 9, when you substitute in the infinity, you actually get an answer, because infinity squared minus infinity is still an infinite, and the square root of infinity is infinity. So 2 over infinity is 0, because remember, as this number gets bigger, the fraction would go to 0. Now the reason why you can put in infinity here, but then you can't up here, is because notice if you put in the negative infinity here, it gives you negative infinity plus 1, which is infinite. And the square root of infinity is infinity, so infinity over infinity is still indeterminate. So that's why you have to do the algebra on number 7, but not on number 9. All right, so let's look at 10 and 11. Well, number 10, notice if you put the 4 in, Notice you get 0 over 0, which is indeterminate. Now, the absolute value of x minus 4 is a piecewise function. So if we take x minus 4, absolute value of x minus 4 over 4, we know that that's equal to 1 if x is greater than or equal to, greater than 4. It can't be equal to 4. And we know it's equal to negative 1 if x is less than 4. So if we take the limit as x approaches 4 from the left, that means less than 4, and we say that is going to be equal to negative 1. The limit as x approaches 4 from the right of the function, that's going to equal 1. Therefore, the limit as x approaches 4 of the absolute value of x minus 4 over x minus 4 does not exist because the limit from the left does not equal the limit from the right. All right, and then the last example, number 11. If you put the infinities in, notice you're going to get infinity over infinity, which means that's indeterminate. So we're going to have to do what we did in number 7, which is multiply. By 1 over the square root of x squared, top and bottom. So the square root of x squared, remember, is the absolute value of x, so we get that in the numerator. And then for the denominator, we get 1 plus 1 over x this time. Or sorry, 1 over x squared, because it's 1, not x. So then we can simplify this to 4x over the absolute value of x plus 7 over the absolute value of x over the square root of 1 plus 1 over x squared. And then when we simplify it, the 4x over x, especially as it goes towards infinity, is just going to be 4. Square root of 1 plus 1 over x squared. And now, when we take the limit, well, we have 4 plus 7 over infinity, and then the square root of 1 plus 1 over infinity. So it's going to be 4 plus 0, and then it's the square root of 1 plus 0. So it's just going to equal 4.